Hello and welcome back at the FinetLink channel. Today we will learn about the Dynamic Host Configuration Protocol, the version 4. This protocol stands for the IPv4 network, which means that you as an administrator do not need to spend time by configuring IP address for every device on your network. When you have a small network, or an office network, it's not difficult to configure the IP addresses of such devices, but in the larger network where you have hundreds or even thousand devices, it goes difficult. So in this case, you will need the dynamic host configuration protocol for configuring and assigning IP addresses to devices. And here in this module, we will learn how to configure a Cisco IOS router to be a DHCP version 4 server and as a client. So what we will learn, it will be about explaining how the DHCP version 4 operates in a small to medium-sized business network. We will configure a router as a DHCP4 server and configuring a router as DHCP version 4 for client. So before we go and do the configuration, first we will explain how the DHCP4 works. And so Dynamic Host Configuration Protocol assigns IPv4 addresses and other network configuration information dynamically. Because desktop clients typically make up the bulk of network nodes, the DHCP version 4 is an extremely useful and time-saving tool for network administrators. A dedicated DHCP version 4 server is scalable and relatively easy to manage. However, in small branches or SOHO location, a Cisco router can be configured to provide DHCP version 4 services without the need for a dedicated server. Cisco iOS software supports an optional full-featured DHCP4 server. The dynamic host control protocol server dynamically assigns or leases an IPv4 address for a pool of addresses for a limited period of time chosen by the server, or until the client no longer needs the address. Clients lease the information from the server for an administratively defined period. Administrators configure the DHCP version 4 servers to set the lease to timeout at different intervals. The lease is typically anywhere from 24 hours to a week or more. Then the lease expires. The client must ask for another address, although the client is typically reassigned the same address. Here in this figure, we have a DHCP version 4 server and a DHCP version 4 client. The DHCP version 4 lease process begins with the client sending a message requesting the service of a DHCP server. And if there is a DHCP version 4 server that receives this message, it will respond with an IPv4 address and possibly other network configuration information. So the DHCP version 4 works in a client-server mode. When a client communicates with a DHCP version 4 server, the server assigns or leases an IPv4 address to the client. The client connects to the network with that leased IPv4 address until the lease expires. The client must contact the DHCP server periodically to extend the lease. The lease mechanism ensures that clients that move or power off do not keep addresses that they no longer need. When a lease expires, the DHCP server returns the address to the pool where it can be relocated as necessary. And there are many steps to obtain a lease. The first step is DHCP Discover. In this step, the client starts the process asking a broadcast DHCP Discover message with its own MAC address to discover available DHCP servers version 4. Because the client has no valid IPv4 information at boot up, it uses layer 2 and layer 3 broadcast addresses to communicate with the server. The purpose of the DHCP Discover message is to find a DHCP version 4 server on the network. After the client sends this message, we will go to the step 2, where the step 2 will be the DHCP offer, and when the DHCP version 4 service receives this DHCP Discover message, it receives an available IPv4 address to lease to the client. The servers also create an RP entry consisting of the MAC address of the requesting client and the leased IPv4 address of the client. The DHCP version 4 server sends the binding DHCP offer message to the requesting client. And when the client receives the DHCP offer from the server, it sends back a DHCP request message. This message is used for both lease origination and lease renewal. When used for lease origination, the DHCP request serves as a binding acceptance notice to the selected server for the parameters it has that it is offered and an implicit decline to any other servers that may have provided the client a binding offer. Many enterprise networks use multiple DHCP version 4 servers. The DHCP request message is sent in the form of a broadcast to inform these servers and any other DHCP version 4 server about the accepted offer. And at the last step, on receiving the DHCP request message, the server may verify the lease information with an Internet Control Message Protocol ping to that address to ensure it is not being used already. It will create a new ARP entry for the client lease and reply with a DHCP acknowledgement message. The DHCP acknowledgement message is a duplicate of the DHCP offer except for a change in the message type field. When the client receives this message, it logs the configuration information and may perform an ARP lookup for the assigned address. If there is no reply to the ARP, the client knows that the IPv4 address is valid and starts using it as it owns. And prior to lease expire, the client begins a two-step process to renew the lease with the DHCP version 4 server as it is shown here. And as you can see, before the lease expires, the client sends a DHCP request, which is the first step, a message directly to the DHCP version 4 server that originally offered the IPv4 address. If a DHCP acknowledgement is not received within a specified amount of time, the client broadcasts another DHCP request so that one on the other DHCP version 4 server can extend the lease. And another message is the DHCP acknowledgement, where on the receiving the DHCP request message, the server verifies the lease information by returning a DHCP acknowledgement. So after we are done with the information, now we will go to the process of configuring Cisco IOS DHCP version 4 server. If we do not have a separate DHCP version 4 server, we will show how to configure a Cisco IIS router to act as a DHCP version 4 server. A Cisco router running Cisco IOS software can be configured to act as a DHCP version 4 server, and the Cisco IOS DHCP version 4 server assigns and manages IPv4 addresses from specified address pool with the router to the DHCP version 4 client. And here will be the network that we will use as example to show the steps to configure Cisco IOS DHCP version 4 server. So let's go through these steps. There are 3 steps that we will use. We will have the exclude IPv4 addresses, we will define a DHCP pool name, and then we will configure the DHCP version 4 pool. So the first step is about the exclude the IPv4 addresses. The router functioning as the DHCP version 4 server assigns all IPv4 addresses in a DHCP version 4 address pool unless it is configured to exclude specific addresses. Typically, some IPv4 addresses in a pool are assigned to a network devices that require static address assignment. Therefore, those IPv4 addresses should not be assigned to other devices. The command syntax to exclude the IPv4 address is here. So we have to be in the global configuration mode, and by using the command ipdhcp excluded address, we will start configuring DHCP version 4 server. A single address or a range of addresses can be excluded by specifying the low address and high address of the range. Excluded address should be those addresses that are assigned to routers, servers, printer, and other devices that have been or will be manually configured. You can also enter the command multiple times for configuring the excluded and IPv4 addresses. At step 2, we will configure a DHCP version 4 server who involves defining a pool of addresses to assign. As it is shown here in this example, by using the IPDHCP pool followed by the pool name, with this command we create a pool with a specified name and put the router in DHCP version 4 configuration mode, which is defined by the prompt that is shown here. And then we will have the last step, which will be configure the DHCP version 4 pool. And here is a table that lists the tasks to complete the DHCP version 4 pool configuration. The address pool and default gateway router must be configured. Use then the network statement to define the range of available address. Use the default router command to define the default gateway router. And typically the gateway is the LAN interface of the router closer to the client service. One gateway is required, but you can list up to 8 addresses, either are multiple gateways. Other DHCP version 4 pool commands are optional. And we have examples. For example, the IPv4 address of the DNS server that is available to a DHCP version 4 client is configured using the DNS server command. The domain name command is used to define the domain name, and the duration of the DHCP version 4 lease can be configured using the lease command. The default lease value is 1 day. The net BIOS followed with name and server command is used to define a NetBIOS Wins server. And by using those 3 steps of configuring in the DHCP version 4 server, let's configure an, and we will have an example. As you see, there is a topology of the network that is shown in this figure, and we will try to configure router 1 as a DHCP version 4 server. And it will be for the network 192.168.10.0/24 for this LAN network. And as you can see, the first 2 rows of the commands are excluding the IPv4 addresses from the DHCP pool. And we use the range, which means what IP DHCP excluded address from 192.168.10.1 to 192.168.10.9. All the IP addresses that are part of this range will be excluded for the IP pool, but even the 192.168.10.254 is excluded. And after we exclude the IP addresses, those excluded IPv4 addresses are for devices that will have a static IPv4 address. For example, servers, printers, and any other devices that we will not change their IPv4 address. And then we will start configuring the DHCP version 4 pool, which means by using IP DHCP pool LAN pool 1, we defined the DHCP version 4 pool name. And then after that, we will define the address pool. And we understand that we are configuring now the pool by the syntax, which means that we are configuring the DHCP version 4 server. And first, we will define the address pool. By using the network followed with the IP of the network and the subnet mask, we are defining all the IPv4 addresses of /24. And then we will configure even a default gateway of the router. And the default gateway will be configured by the command default router followed by the default gateway of the network, which means by the gateway, the IPv4 address of the router 1 of the subinterface giga 0/0/0. And we will configure even DNS server, and we will configure even a domain name. So these are all the commands that we will use. And every time we do some configuration, the next step is the commands that we will use for verification of the DHCP version 4 in this case. So all the commands will be shown here in this table, and are the commands that we will verify that Cisco IOS DHCP version 4 server is operational, which means by using the show running configuration followed with the section DHCP, we will display the DHCP version 4 commands configured on the router. With show IP DHCP binding, with this command, we will display a list of all IPv4 addresses to MAC address binding provided by the DHCP version 4 service. And with show IP DHCP server statistics, we will display count information regarding the number of DHCP version 4 messages that have been sent and received at the server. So, depending on those commands that are shown in this table, and let's go in our example where we have a topology of our network that we configured before. And by using the verification command, let's see if the PC1 will power it up and see if we will have an IPv4 address. So the first step, we will verify that all the configuration at the DHCP version 4 server at the router, it is configured as we want. So by using the show running configuration section DHCP, we will see all the commands that are configured on the router 1 only for DHCP version 4. And as you can see, we excluded the IPv4 addresses, the range from 192.68.10.1 to 192.168.10.9. We have excluded even this address, and we defined the pool name, we defined the range of IPv4 network addresses for the LAN network. We configured a default gateway where it's the IP of the router, and we configure the DNS server and a domain name. And the next step is verify the DHCP version 4 bindings by using the show IP DHCP binding command. We'll display a list of all IPv4 address to MAC address binding that have been provided by the DHCP version 4 server. And as you can see, it is provided this IPv4 address for this client, which have this MAC address. It means the time when the lease is given and the expiration. It is get automatically, it is active, and it is provided by this interface, which is the interface of the router. Then we will have verification of DHCP version 4 statistics, which means by using the show IP DHCP server statistics, there are all the messages that have been received or sent by the router. And as you can see, we have one address pool. There are sent 4 DHCP discover messages to DHCP request. And this is at the router. Now we will go and see if the client is able to receive an IPv4 address. For doing that, we have to go in our PC1 at the command prompt, and by using the ipconfig/all, we will display the TCP IP parameters as it is shown here in this example. And because the PC1 was connected to the network segment of 192.168.10.0, and it is configured automatically to receive an address, a DNS suffix, and a subnet mask, and a default gateway from the pool, you can see that the computer got the DNS, the domain name, got an IPv4 address that we saw even at the binding, got the default gateway, which is from the pool, and got even a DNS server that is provided from the DHCP version 4 server that is defined at the pool. So all the configuration are done correctly, and the computer was able to get those information from the router acting as a DHCP version 4 server. The service of DHCP version 4 service in a router is enabled by default. In case you need to disable this service, you have to use the no service DHCP command in the global configuration mode. And if you want this service to be re-enabled for the DHCP version 4 server process, you have to use, again, in the global configuration mode, the service DHCP. Clearing the DHCP bindings or stopping and restarting the DHCP service may result in duplicate IP address being temporarily assigned on the network. That makes pretty sense, and so in case you have to disable or re-enable the DHCP service in the router, you have to check your IP addresses in the devices, or in this case you have to turn off the network and restart it again, so they will not have the duplicated IP address. And the last thing that you have to know about the Cisco iOS DHCP version 4 server is the DHCP version 4 Relay. Because in a complex hierarchical network, enterprise servers are usually located centrally. These servers may provide DHCP, DNS, TFTP, and FTP services for the network. Network clients are not typically on the same subnet as those servers. And in order to locate the services and receive those services, clients often use broadcast messages. Here in this figure, we have the PC1 that is attempting to acquire an IPv4 address from a DHCP version 4 server by using a broadcast message. Here in this scenario, the router 1 is not configured as a DHCP version 4 server and does not forward the broadcast. Because the DHCP version 4 server is located, as you can see, in a different network, PC1 cannot receive an IP address using DHCP. Router 1 must be configured to relay the DHCP version 4 message to the DHCP version 4 server. So, the first thing you have to do is ipconfig release. Here it will be done in the computer, which means the PC1 is a Windows computer. The network administrator releases all current IPv4 addressing information by using the ipconfig/release command. And with this, you will see that all IPv4 addresses is released and there are no addresses shown. The next step is using the ipconfig renew, which means that the network administrators will attempt to renew the IPv4 addressing information with the ipconfig renew command. This command will cause the PC1 to broadcast a DHCP discover message. The output shows that the PC1 is unable to locate a DHCP version 4 server because router do not forward broadcast. The request is not successful. In this case, the network administrator could add DHCP version 4 server on router 1 for all subnets. However, this would create additional cost and administrative overhead, which means that we have to use IP helper address, which means this is a better solution than in the router 1. We have to configure it with the IP helper address followed with address interface configuration command. With this, we will cause router 1 to relay the DHCP version 4 broadcast to the DHCP version 4 server. As it is shown here in this example, the interface on router 1 receiving the broadcast from PC1 is required to relay DHCP version 4 addresses to the DHCP version 4 server at 192.168.11.6. And if we use the show IP interface in Giga 0/0/0, you will see that the router 1 has been configured as a DHCP version 4 Relay agent. It will accept broadcast requests for the DHCP version 4 service and then forward this request as unicast to the IPv4 address 192.168.11.6, and the network administrators can use the show IP interface command to verify this configuration, as it is shown here. And the last step is we go again to our computer PC1, and now by using the ipconfig all, we will be able to acquire an IPv4 address from the DHCP version 4 server as verified with the command ipconfig all. And as you can see, now we are able to have an IPv4 address, a subnet mask, and default gateway, all those information provided by the DHCP version 4 server with this IP address. And after we are done configuring our router as a DHCP version 4 server, let's configure those routers as a DHCP version 4 client. Because there are scenarios where you might have access to a DHCP server through your internet service provider, and you can configure a Cisco iOS router as a DHCP version 4 client. So sometimes Cisco routers in a small office or home office and branch sites have to be configured as a DHCP version 4 client in a similar manner to a client computers. This method used depends on the internet service providers. However, in its simplest configuration, the Ethernet interface is used to connect to a cable or a DSL modem. To configure an Ethernet interface as a DHCP client, we have to use the IP address DHCP interface configuration mode command. Here we have this figure, and we will assume that internet service provider has been configured to provide select customers with IP address from addresses 209.165.201.0/27 network range for the interface giga 0/0. This interface is configured with the IP address DHCP command, which means that to configure an Ethernet interface as a DHCP client, we use the IP address DHCP interface configuration mode command as it is shown here in this example. So we will go to the interface and we will use the IP address DHCP command followed with a not shutdown. This configuration assumes that the internet service provider has been configured to provide selected customer with IPv4 addressing. And then if you use the show IP interface giga 0/0/1 for this interface, now we will able to see that it is able to get an IPv4 address from the internet service provider, and the address is determined by the DHCP server that is provided by the internet service provider. And home routers are typically already set to receive IPv4 addressing information automatically from the internet service provider. This is so that customers can easily set up the router and connect to the internet. For example, let's show this figure and see that the default one setup page for a packet tracer wireless router. And as you can see, the internet connection type is set to automatic configuration, DHCP. This selection is used when the router is connected to a DSL or cable modem and act as a DHCP version 4 client, requesting an IPv4 address from the internet service providers. And this is for all the wireless routers that we have in our home or in our small business. And that's it all about the configuration of a DHCP version 4 as a server and as a client in the router, and the next step will be in a packet tracer, where we will implement a DHCP version 4, and as a network technician we are tasked to configure a Cisco router as a DHCP server to provide dynamic allocation of address to the client on the network. We will see that where we will do our practice in the other video. So for this theoretical information about the DHCP version 4, that was all about, and see you to the next session. And for those who are new at this channel, do not forget to subscribe and share the video if you like it with your friends. See you soon.